Good afternoon, internet friends. Buenos tardes, boa noite, whatever you say. And welcome to Dev Update number 0. I'm calling it number 0 because I realized that in addition to one per sub-milestone, I should also do a separate one at the beginning about how to set up all the software I use in my dev environment, because that was taking up a lot of the first one. Okay, so first of all, this is the GitHub repo here. It's my handle, ElectionGuard Cardano. And then I've got it organized by catalyst milestone, and then within each milestone, there's the first milestone here, within each one of those, there's subfolders with each one has its own little dev environment, so I can do lots of different experiments simultaneously. So here's what that looks like in the terminal. You can see I'm inside the repo here. So if I look at the directories in here, each one of these is its own little dev environment. They're all semi-independent. Okay, so let's look at the first one. There are a bunch of files here, and instead of saying what they do directly, I want to go talk about the dev setup conceptually, and then at the end of the video, we can come back and do a little recap, and you should understand what all of these standard ones do. And then the last couple that I'm not going to talk about here will be in the next video about running the election script. My personal setup is very Nix-centric, so we should talk about Nix first. So what is it? If you go to the website, it'll tell you that it's reproducible, declarative, and reliable. And that's true, but it doesn't really tell you what it is. So I think the simplest way to explain it is that, you know how in any language package manager, you'll generally have a lock file. So like if you're in JavaScript, it would be packagelock.json. If you're in Python, it might be a poetry lock file, that sort of thing. Nix is like a universal version of that works across all languages. So it lets you pin exact versions of everything, your entire operating system, down to like your C compiler and your shell and all the little bits that sound boring and you don't want to have to manually tell people how to install them. It just automatically handles all of that. So that's what makes it awesome. You can kind of see how they say that in a roundabout way. That makes it so that if your build works on your machine, it'll pretty much work on anyone else's that has Nix. And this other part that I think they don't emphasize enough is that it's a polyglot package manager. So it's usually not worth using Nix if you're only using one language. Like if you're only using Python, you might as well use one of the Python package managers. It'll be simpler. But if your project is going to use, say, Python and JavaScript and Haskell and maybe Rust, you might not even know what language it'll use at the beginning, then Nix is the simplest way to make sure you can support all of them and have them integrate well. Another tool I use a lot is Docker. It doesn't need much of an introduction because, like it says, it's very popular. But basically, it lets you download prepackaged containers, which are like lightweight little virtual machines. Each one has an application and a whole operating system with everything set up to run the application. So if you want, for example, a Cardano node, there's a Docker file for that, and you can just run it and it should work on your host operating system without any extra configuration. And the real killer feature of Docker, in my opinion, is Docker Compose, which lets you take several different Docker containers and wire them up with a little internal network so that they can talk to each other in pre-specified ways. All right, so we've got Nix and we've got Docker. This might be obvious, but it also ends up mattering which operating system you use. It needs to be either Linux or Mac OS for now. It's possible to do workarounds that work on Windows, but it's not worth it since this isn't a production app, it's just a demo. So far, I've described having a few different developer environments and using Docker and Nix. And so you might assume that some of the environments use Docker and some use Nix. But actually, what I want to do is combine them. I've become a big fan over the last couple months of using both of them. They're really nice together, much better than either one alone. I'm not sure why, but I don't see very many people doing this. And so maybe that can be the unique contribution of this video, is showing people how to do that smoothly. The way I do it is with this lesser known project called Arion. I'm not sure it has an official logo, so I'm just doing my interpretation of the Greek horse it's named after here. But basically what it does is use Nix to generate Docker images and Docker Compose files. And that has three major advantages. First advantage is that you can take a Nix package and deploy it as a Docker image. So Nix is, in my opinion, nicer for development, but Docker images are easier for end users to set up. The second thing is it lets you incorporate things that are only available as Docker images into your dev environment. You don't have to Nix package everything. And then the third thing is hinted to down here, but not really explained, which is that unlike a Docker Compose file, an Arion Compose file is just Nix, and so it can be dynamic. For example, instead of making one Cardano node, you can make a list of 10 Cardano nodes and programmatically have them all on a list of 10 different ports and hooked up to 10 other things in a particular order. It's a lot easier to orchestrate complex things than with Docker Compose files. Now that we've got everything set up, we're just about ready to start writing the actual top-level script that'll do something useful. In this case, it'll be running a mock election. Now I'm using a Python script here, but it could be a shell script or whatever. I'm just doing that because the ElectionGuard code is in Python, so it's convenient. Now almost all the pieces are in place. I just want to show you one other trick that I found useful, which is to make one main JSON config file and then read it from both the Python script and the Arion Compose file. That way I can tell Arion how many of each type of container to generate, and then have that same info available from the Python script so that it knows how to handle each of the generated containers. Finally, for completeness sake, I'll put in some arrows to show that the top-level script can also access and depend on things further down in the dev stack. Alright, so now if we go back and look at the files, you should recognize most of the things. First of all, we have flake.nix and flake.lock. Those define our Nix environment. And you can see in the flake.nix, we've got general dev tools, including Arion, and then Python packages. And then the Arion things, there's this Arion packages, and that you don't really have to read this. It's some boilerplate that imports everything from the flake.lock file, so we can use it in Arion Compose, which is what's going to generate our Docker Compose file at runtime. And I guess the only other thing to mention here is that you can see that it imports election.json here, which is the main JSON config file. That's this one. And there's some Arion specific stuff, and then some general election things that control how many of each type of container it generates, that sort of thing. And then the top-level script election.py also reads the config file down here. I think that's about it for now. Thanks for sticking with that fairly long-winded explanation. Now that we've got the boring part out of the way, join me in the next video and I'll show you what I've been working on as far as cryptographically verifiable elections.